Hello. Hi, I'm Rachel. I'm a practitioner in paid media, and I'm going to be talking today about cloud and machine learning. A little bit about me first. I'm actually from the agency side originally, where I dabbled in SEO and analytics, and then I moved to conversion rate optimization before going client side within Google Cloud. So here I work on the B2B project. I work on G Suite, which is the B2B version of Gmail and Drive, and I work on Google Cloud Platform. I spent 2 years running paid media in EMEA and doing conversion optimization experiments before moving to a more tools and tech role. So I set up the tools, the technology, and the processes that our teams need in order to be doing their own projects. So today, I'm going to talk about a scenario that I think many of you might have encountered in various forms throughout the years. Imagine this. You get an email, and it comes through from your CEO, and it says, "Hey, I was reading this article about machine learning. Sounds exciting. Can we do some machine learning?" Your first reaction, it's probably something like this. No. But nevertheless, you need to respond. And so you start to think. You go, is this like the time that I learned JavaScript in order to do my A/B test? Or the time I learned Photoshop in order to turn that button blue? And so you start to Google. And within a few minutes, you're knee-deep talking in Python about TensorFlows and SciPy, and you just have a sudden urge to tidy your desk area. This was me about a year ago. But I did, with a team, manage to actually do a machine learning project from start to end. I learned a lot. It's incredibly hard, and there's a lot of prerequisites. But along the way, I was able to actually go through and create a set of tasks that are needed to do a machine learning project, and that's essentially what we're doing today. So I'll be running through the steps to do machine learning in a conversion project. So what do you need first? The first thing that I did, it was really the reason why the project was a success. I looked, and I decided, as a marketeer, if you want to do data science, probably hire a data scientist. I know that as in-house marketers or agencies, we're used to being like a Swiss Army knife. We've got a broad set of skills and competencies, and we're brilliant at learning new things. That's great, but having done the machine learning project now, I can safely say that we're not quite in a position where we can just do it. We need the broad knowledge, the depth, the coding skills of an actual data scientist, although I'm really hoping that's going to change over the next few years. So my advice is make a business case, try and get ahead, try and get a freelancer, try and team up with another team, find a random data scientist and ask them to help you with your project. It will make it go so much smoother and also to a better time frame. So let's imagine you have this data scientist. The first thing you need to do is then knowledge share. So we got our data scientist, and he knew a bit about the potential areas that he could help us with because he'd used similar data sets. And I knew nothing about machine learning, but thought it was cool. So we kind of sat down, and we started to talk. And I explained the fundamentals of conversion and paid media and how our teams work. He explained the fundamentals of machine learning. And we very quickly realized that is not enough. And so we both went away for a couple of weeks. And he actually ended up going through and doing the Google Ads Academy and the fundamental exams. And I went away and I did Google's machine learning crash course, which were both really fun and external if you do want to do them. So what did I learn whilst learning on a crash course about machine learning? The first type of thing that I think everybody learns is a sentence that doesn't make any sense. So this was, a computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance at task in T, as measured by P, improves with experience E. Does everyone get it? So I did a little bit more digging and found some friendly images. And I essentially learned these few facts that I think are core to doing a machine learning project. First of all, you need a task. And that task is going to do something. That's the model. For that, it needs a bunch of data sets. And this data set is an experience, and it will feed into the task. You then need a measure of performance. That's a way to measure if the task was a success. And essentially, what machine learning does is it starts to use more of these data sets to perform this task, to understand its performance. And as it understands its performance, it can start to learn if it's doing a good job and use more of the data sets to do more of the things, and that's essentially how it learns. This is the core concept of doing machine learning. So what did our data scientist learn? He learned a lot about the technical capabilities and paid media in general, but there's two key things that he took away. One is that we use a tool called AdWords to do our paid search, and that has bidding optimizations. But what he found really interesting is that you essentially have an account structure. You have the ad level, the account level, and then you have the campaign name, and then you have the ad groups, and then you have keywords. And these keywords have measures like impressions, click-through rates that feed into how it's performing. He also learned that we had two different types of campaigns. We had the always-on campaigns that were forever going, and then we had one-off campaigns, ones with a start and an end that flowed and went down. This essentially gave us both the right amount of knowledge to then start to brainstorm different areas that we could actually think about using machine learning for. So that's what we did next. We needed to decide on a project area, and there's two main things to do with this. First of all, you need to find one specific thing that you can create a model that can then learn what to do. You also need to make sure that you do something that will actually add value, that actually needs machine learning. If it's a simple rules-based thing, it doesn't really need machine learning. It has to be more complicated. So I'm going to go through the different tasks that we came up with and how we went from something abstract to actually something we could do with machine learning based off these two concepts. First of all, we had a great idea: measure our ad campaign success. Isn't this great? You'd launch a campaign, you'd do machine learning, the next day you'd figure out if it's successful. Brilliant. It's a little bit vague. So we looked at it and we're like, okay, what do we actually mean by an ad campaign? Which element of our ad campaigns are most going to be useful for machine learning? And so we talked about awareness campaigns and how we had these huge campaigns with an offline element and an online element. But we very quickly saw that that's not a great example for the first machine learning project, because stitching offline to online data is kind of an entire project within its own right. So then we looked at that always-on campaign that we talked about, and that one seemed better. There was a consistent budget, there was a consistent data set, and we did a lot of testing on it. So that seemed to be a really good area to work with. So we changed it to be measure our direct response, always-on AdWords campaign success. Fantastic. But what does success actually mean? I mean, if we just see success as something that's a cost per trial, that's simple. We can just use cost per trial. There isn't much point to actually use machine learning. It doesn't add any value. So we went away and we talked to the different teams that ran paid media, and we tried to figure out where they actually had a problem that could be solved. And we came up with one that I think many of you might have encountered in the past. We have a website, and we have ads that we send to our website that become trials. Fantastic. But trials isn't the key performance indicator. It isn't our measure of success, because they're just in trial. That is actually customers, the point that they start paying money. Now, at the time, our trial was actually 4 weeks long. And so when you took into consideration the different other things that happened, we actually found that we had a 6-week delay from the time that the trial started to when we could see in our customer data our ads and how they were performing. So how did our paid media team actually optimize then? Well, we found what they were doing is they were basically doing an automated cost per acquisition based off trial, and then 6 weeks later, they would do a manual adjustment based off what they saw from the trial to customer conversion rate. That's a problem. They've got to wait 6 weeks. That means that when a campaign launches, they wait 6 weeks, and then they can finally start to do conversion tests and what they're seeing, which means that we can only do 2 per quarter. So this is a problem that can't be solved by a simple rules-based approach. We can't be there and go, okay, well, we can make general assumptions. So maybe country A performs better than country B and always converts better, so we could put more money there. That's okay, but it's not a day-to-day optimization. And we can't say if it is a broad match or if it's an exact match, it's more likely to convert into a customer. That's too simple. In fact, we could use several rules, but they're always going to be too simple. Step in machine learning. What if we could use machine learning to predict which trials that we had were going to convert into customers? Machine learning can use millions and millions of data sets. It can crunch a ton of data. It could take all of our sources, all of our data sets, and try and figure out if they're indicating factors for the trial to customer conversion rate. And so this is a great example, because then we could reduce our optimization period from 6 weeks to 2 weeks, and it's a specific task that could be done. So this is the area that we chose. We changed from a more generic measure our direct response always on AdWords success to predict which trials from our direct response always on AdWords campaigns will convert into customers. We had our task. We're nearly ready to go. But wait, there's always prerequisites. And so at the end of this, I learned that there's actually a number of things that you have to have already done if you do want to do a project to begin with. And it's always good to know that up front rather than when you get to the moment that you want to start. So it falls into 3 categories. The first one is people. You need a project team. And so this will include the data scientists we talked about. You then also need an end user or a representative of your end users. In this case, this was me. So I was representing the 4 teams around the globe that all were running paid media. And I had to make sure whatever we set up would really work with the way that they ran. We then also had a project manager who would ensure that we got all the approvals and all of the sign-off. And finally, we had an exec sponsor that was an advocate for the project, and that was the person who emailed us in the beginning. So we had a project team. Next up, data. This one's a big topic, and it's one that I can't touch upon because I just don't have time in this talk, but I think Ed's talk on Wednesday was fantastic at kind of doing that. So you need a data set, and it needs to be clean. If you are sitting there and every time you mention your data set, you are scrunching your face up, it's not going to be a good data set for machine learning. Tidy and trustworthy data, it's fairly critical to machine learning. And this is for 2 reasons. First of all, the quality of the data that comes in will reflect the quality of the model that comes out. But also, if you have messy data, your data scientist is going to spend ages just messing about trying to make your data cleaner. So ensure that you have tidy and trustworthy data. Next up, a good taxonomy. Taxonomies are fantastic. They're a bonus for machine learning. Because what essentially happens is the task it uses the experience, uses the data sets. And it can either use the entire experience, or it can take each data set and make it into smaller data sets, and then use all of those individual data sets to form the experience. Complicated? Let me show you an example. So here we have campaign names. And in this campaign name, it's not that clean, it's not that consistent. And therefore, the task, it can only really use the entire campaign name, or you're setting up a ton of rules to try and dig further. If you use a taxonomy, however, for example, let's say every campaign name, it starts with region, country, product, and then match type, it means not only can you use the full campaign name, but you can also use the individual parts. And so your machine learning model, it can understand if product has an impact on the conversion rate, on the task, or if country does. And that provides a far richer data set, although you do always have to worry about the trade-off with volume. So we have our data. Now we're ready for our access. You need to make sure that you and your data scientists can access all of the data that you're going to need to use. You also need to make sure that they can access a big database that you might put your different data sets into. And then you need to make sure that you can access some sort of machine learning tool, which I'll talk about in a bit. So you have your data, you've got your people, you've got your access, you're ready to design your project flow. And so this is really bringing together what we saw at the beginning with the experience, with the task, and with the performance. So we had the task. predict the trials that would convert into customers. And that's our task that we're achieving. We then had the data sets that would feed into this. And then we had the analysis, the performance measure that would update our model. So as the data came in, it would understand if it had done a good job. Now for us, we actually had the actual data 6 weeks later. So then the machine learning model could go and see 6 weeks later how accurate it was at the beginning. This would reduce from 6 weeks of optimization, as we said, to 2. And then adjustments would be made and the cycle of life would happen. Our project flow. So the data sets. You need to select your data sets and to work with the data scientists to figure out which ones should be ingested and which format they were needed in. For us, it was a little bit simpler than the average person because we all use Google products. So we were on the Google marketing stack with our DoubleClick AdWords, Google Analytics, etc. All of these flowed through into BigQuery where the data was stored. And then we use Google Cloud Platform's machine learning API, which is TensorFlow, to then actually do the analysis. This is one set of tools that obviously I'm going to think are really great, but there's many out there that you can also research. So we've got our data sets, we're ready to get our approvals, and this is really important. First of all, you need approvals from all of your project team and also from your end users. This was important from us from the beginning because we wanted a tool that would be used really actionably every day to day in how they optimized, and not a shiny dashboard if they're sitting there needing something in AdWords. We essentially wanted this to become an integral part of life and not just a shiny case study for these types of conferences. We then also needed to make sure that we had privacy sign-off, and this is so important with machine learning. Machine learning will combine different data sets together, and when you do that, you need to understand the privacy and the legal implications of doing so. We have a team that we can go to for sign-off, but even if you don't, regardless, you should ensure that you're adhering to each of the individual tools' terms and conditions and the law, particularly if you're in EMEA. So you've got your approvals, you're ready to sit back. Might not be just this easy. However, you should sit back, and this is the time that the data scientist actually goes in and creates the actual model of prediction. It's created. And so now we're there to start to stress test it and start to look at what needs to happen before it goes live. First of all, we launch a pilot in one market, and we just check to see how it goes. Things always look a little bit different when you actually launch. So we tested, we made some modifications, see how it went. The second side is building trust. This is very important. Machine learning is new, and many people are very apprehensive about it. It only takes one team member to go, I don't really trust this, or I think that prediction looks a bit wrong, or I just hate machine learning and its use in conversion, for like months and months of hard work just to unwind. A tip that I found to work quite well is to essentially find out a benchmark of what people are comfortable with. So this is like statistical significance. You create an arbitrary number. So our number that we saw that our team was happy with was 95%. If the model showed that its prediction rate was 95% successful or more, then people were happy to use the model. So before it launched, we set up a dashboard, and in that dashboard, we showed how successful the model was in real time. So each team member could come in and be like, oh, 95%, okay, I'll use this, I trust it. So it's time to launch, and to test, and to report, and to iterate. And this is just really the beginning. You keep going, you figure out new projects, go from there. Our trial to conversion project was a great success. When it launched, we were instantly able to see which trials were more likely to convert into customers. Around a month or two in, we then launched a new campaign, and that new campaign was based off the keyword expansions that we'd done in paid search. When we launched it, we then found out that it wasn't performing quite as well as all of the other campaigns. And so we segmented it. We continued with a small part of it, and it went live to test if the model was correct. But then on the other side, we paused the majority of it. We went back to basics, did a bit more research, tweaked our campaign, launched it again, and we saw that now there was a similar trial to customer prediction rate as everything else. The other thing we started to do was started to use it for conversion projects. So we have these source signals. And so we thought, wouldn't it be cool if we could use the data, use what the machine learning model is saying is more likely to convert into customers and run projects to try and increase spend or increase conversion in those aspects. Or, because it's so complicated and it's a model that has many different weightings, will we just be offsetting another part of the model? So we launched a number of ones, and then we saw that actually it's more complicated. You can't see that one tiny element is more likely to increase predictions and then put spend to that. Okay, so we have our test, we have everything. So next time that you have your CEO saying, I was reading this article about machine learning, hopefully instead of going away and having an awkward silence, you'll be able to be in a position to give a quick answer, even if that answer is potentially no. Now, you might be sitting here and being like, I want to do this tomorrow. Or you might be sitting here and being like, I lost you at clean data. If that's the case, there is hope. As Guy mentioned yesterday, we're actually starting to see more tools embedding machine learning in their projects. Or in their products. So what you can do is just find these examples and then share them. So in attribution, data-driven algorithms often are fueled by machine learning. A360 uses one. Or in AdWords, there's this tool called smart bidding, and it uses machine learning to define the optimal bids. In A/B testing models, many of the tools will use machine learning at its core. Just pick one, share it, and then start a conversation as to what you could do in future. Although machine learning can be a bit of a buzzword and it can be something that's met with quite a fair bit of resistance, I do really feel like it is going to be huge and is going to be really important in the future. I'm really excited about it, and I'd love to hear different thoughts or ideas that people have for projects that they would like to do. Thanks, and I'm Rachel.